Today we'll be looking at a very lovely question in physics. Welcome back to class, everyone. Today we will be looking at a very important question in physics. Don't skip any part of this video because this question is very important. In order to get the full explanation, you must watch this video from the beginning to the end. Don't skip any part. The question is: charges Q1 and Q2 lies on the s-axis at point S equals to minus A and S equals to plus A respectively. Now, question I. How must Q1 and Q2 be related? For the net force on charge plus Q placed at S equals to plus A over 2 be 0. Question 2. Answer the question if the plus Q charge is placed at S equals to plus 3A over 2. I'm going to explain this one after the other. Now, they said charges Q1 and Q2 lies on the x-axis. So the first thing you do, you first of all draw s-axis, which is the horizontal axis. This is, as you are seeing now, that is the s-axis. This is the s-axis. First of all, draw this horizontal line. Then you start placing your charge at the right location. Now, the first you choose origin. Origin, you will be the one to just choose. You will be the one to choose the origin. So I chose my origin here, which is where x and y meet. So I just called them my origin. The distance at the origin is 0. X is 0, y is 0 at the origin. So here is my starting point. They said Q1 and Q2 lies on the x at S equals to minus A. Now to the left, S is negative. So if you see minus 2 meters, that means you are going to measure 2 meters to the left. That is the meaning. It means you are going to the left. So that's why the first A here, which is minus A, I placed it at I measured A meters to the left hand side, because this one is minus A, because this place S is negative. So this side is minus X, this side is minus X, this side is minus X, this side is minus X. Then this second side is plus X, plus X, plus X. So if you want to, this one is minus A now, going to the left hand side. Then Q2, so I placed it here. Measure from here to here is A, which is Q1 to the left or to the negative side. Then I measure another plus A, means you measure another A to the plus side, which is the positive side, which is from here to here. Call it A. I place my Q2 there. So Q1 is for the first distance, Q2 is for the second distance. That's why they said respectively. Now, they just said how must this Q1 and this Q2 be related? So that the net force placed on charge plus Q, the net force on charge plus Q placed at S equal to A over 2. A over 2 means half A. When you divide, but it's plus, that means you go to the right hand side. So I measure half A. Yes, you divide this A by 2 self. From here to S, A divided by 2, you will have half A. So from the origin to this place now, I just called it half A. I place my plus Q there. This is the third one. So if from here to here is half A, from here to here also be half of A, because the full distance is A. So if you divide 8 by 2, you are going to have half of A. So the next thing we check, what force will this Q1 exert on this plus Q? Since both of them are positive, there's no sign here, there's no sign here. So this one is positive, this one is positive. This one is also positive. So this Q1 will be repelling this plus Q to this side, since both of them are positive. So the force coming from here will be force of repulsion, which repels this to this side. That's why this one is going to this side. This one will be trying to push this one to this side. That's F1, force coming from Q1. Then Q2, the same thing, will be repelling this plus Q to this other side. So This one will be pushing it to this other side. This one is pushing it to this side. This one is pushing it to this side. That's why I call this one F2. Force coming from Q2. Now, how do you calculate F2? How do you calculate Q2? You must know the distance between Q2 and plus Q, Q1 and plus Q. And the distance between this and this will be this from here to here, which is A. Don't add minus again. No. Minus tells us that it's going to the left hand side. Measure to the left hand side. So from here to here is A already, plus from here to here, which is A over 2. So A plus A over 2 gives us 3 over 2. So that is the distance between this and this. The distance between Q2 and plus Q is already A over 2. It's already over 2. We just something like remove A over 2 from this full distance, which is A. You're going to have A over 2. Now from Coulomb's law, let's calculate F1 and F2 to check the answer for that. Now from Coulomb's law, F1 will be KQ1 Q3 over arrow square with the arrow between Q1 and Q3. So Q3 is plus Q, Q1 is Q1, K is K, but arrow 1, the distance between Q1 and Q3 is 3A over 2. So just do your substitution, put your 3 over 2 here, which is arrow 1, then square it. So 3 square will give me 9, A square will give me A square, 2 square will give me 4. So this 4 will move up to multiply this numerator. So 4 times everything here will give me 4K Q1 Q2. Then everything over 9A square. So this 4 will move up over 9A square. Then F2 will be the force between Q2 and Q3. Quantity here KQ2 Q3 over arrow 2 square. Remember the distance between Q2 and Q3 is A over 2. So we put A over 2 here. Q3 is just capital letter Q. So A raised to power 2 gives us A square. 4 and 2 raised to power 2 gives us 4. So this 4 will move up to multiply this numerator. We're going to have this. So the net force will be, remember our F1 was going to the right hand side to be positive. So our positive F1. Then F2 is going to the left hand side, negative F2. Then they said how much Q1 and Q2 be related so that this net force here will be equal to 0. So if this is equal to 0 and you move it onto this other side, F1 will now be, if plus cross this sign, we change to plus F2. So F1 will be equal to F2. So you break your F1, you already calculated, look at F1 here, look at F2 here. So just substitute them into this place. We'll have F1, F2. So this 4K will cancel this 4K, Q will cancel out Q, A square will cancel out A square. What will be left to be Q1 over 9 is equals to Q2. There's everything left there. Everything is out. The rest is off. So I'm going to have Q1 over 9, then it's equal to Q2. So this is the first relation, that Q1 over 9 must be equal to Q2. Or if you cross multiply 9 times Q2, you're going to have Q1 is equal to 9Q2. Or if you move this one to this other side, you're going to have Q1. If plus 9Q2 move to this other side, you just turn to minus 9Q2 must be equal to 0. So say that this relation or this relation or this relation. The relation between Q1 and Q2. That's how they be related. For the net force placed at A over 2 on charge, and for the net force on charge plus Q placed at A over 2 to be 0. Now let's look at the other part of the question, which is part 2. We now place this charge at 3A plus 3 over 2. Alright, this is the second question, although we are still in order. Still almost the same thing. This is the origin. This is the first charge here, which is at distance A to the left. The other charge distance A to the right. They are telling us if we place this plus Q at plus 3 over 2. Plus 3 over 2 is same thing as A 1.5 A or 1.5 A, that which is more than 1, just 1 A. So you're going to measure, it's already more than A. So you measure 3 over 2 to the left and to the right because it's plus. So from here to here now we assume it to be 3 over 2. From this place to this place. We assume it to be 3 over 2. Then what will be the distance now between Q1 and this? That will be from here to here, which is A over 2 plus 3 over 2. A plus 3 over 2. From here to here is A. Here is the origin. So from here to here is A. From here to here is 3 over 2. If you add it together, I'm going to have 5A over 2. That's what I'm going to have. What about the distance between Q2 and the Q? It will now be from here to here, which is 3 over 2, minus from here to here, which is A. That will give us A over 2. That's what we are going to have. Now, in the same way, let's calculate F1 and F2 now. Let us first check for their direction. Now, this Q1 will be repelling this towards this to the positive S direction, because if you check it very well, you discover that this is positive, this is also positive. So this will repel this one to this side. This will also be repelling to this side. This is also positive, positive. This one also repelling it. Discover both of these two forces are going to the same side now. Since both of them are forces, they are force of repulsion. So we're repelling the charge toward this other side. That's what we'll be doing. This one will be repelling to this side. This one will be repelling to this side. So the next thing we're going to do now, let's calculate the values or the magnitude of the two forces. So the first one, which is F1, we have KQ1, Q3 over R1 square. So substitute their respective values. So I'm going to have this. 5 square will give me 25. A square will give me a square. 2 square will give me 4. Square multiply this, we're going to have this. Therefore, F2, KQ2, Q3 over R square. Then, on substituting, you're going to have this. The sum between Q2 and Q3 is this. But the result between Q1 and Q3 is this. Take note of that, so you don't miss the labeling. So, if this 4 cross multiply to multiply this on upper side, you're going to have this. Just move this one. It's not cross multiplication. Just move this 4 to go and multiply the numerator. Then we're going to have this. So the net force one will be F net is equal to plus Q1, because it's going to the right hand side, plus Q2 also go to the right hand side. Then the net force, if the net force is 0 now, what will be how Q1 and Q2, how must Q1 and Q2 be related if this net force is 0? So this one is go to this side, will be positive. Second one is also go to the same side, so it will be positive. So the net force will be dx plus dx. So if you move it on to this other side, we're going to have minus F2. So F1 will go to minus F2 for both of them, their net force to be 0. So after this, let's substitute the value for F1 and F2 now to see what we're going to have. So we're going to substitute our F1 here, then our F2 to be will be here. Our F2 will be here. Then 4K we cancel out 4K. Q will cancel out Q. A square will cancel out A square. And we'll be left with Q1 over 25 is equal to minus Q2. So Q1 over 25 is equal to minus Q2. That's the first relation. Or if you cross multiply 25 to this side, we're going to have Q1 is equal to minus 25 Q2. Or if you move everything to the same side and equate it to 0, if you move it to this side now, only not will be left to this other side. We're going to have Q1. If plus crosses this side, we're going to have plus 25. If minus crosses, we're going to have plus 25. Q2, everything will not be equal to 0. So the relationship is either this or this between Q1 and Q2. Or if for the charge plus Q placed at that 3 over 2 to be 0, for the force on that charge to be 0. So we're going to have those respective relations. Thank you. God bless you.